So after we take a look for availability and interoperability, now we will take a look into the modifiability. This is also one of the important quality attribute or architecture characteristics that and we have to pay attention for that one, especially nowadays, since during the almost all time the software are changed. So modifiability, it is about changes. As you know, that almost all software is always changed. There is no time when it is just a constant that is never changed. So it happens always. That's why we have to keep in mind that during the design phase, we have to include this behavior to the software to be flexible for modifications. And when we start thinking about modifiability, we have to consider next questions. What can change? What this question is about? This question is about that in general, every component of the system can be changed. The function that it works on, the platform, the environment, and so on. What is the likelihood of the changes? Is it possible to design a single system that will cover all potential changes, the system that will never? So I guess the answer for this question is no, because you will never finish implementation of such system. Or in case if you will try to implement the system that will cover all potential changes, it will be too expensive, or so it very complex task. Another one question: when is the change made and who makes it? Is it the developer make some changes, or maybe this change is related when QA member of the team noticing something and request some changes, or during the deployment phase. So it can be during different stages on when you're working with it. What is the cost of change? While thinking about this question, we have to understand what makes it. So it makes the cost of making is the modification using the mechanism, or do we have some tools that will be able us to make such changes? Let's switch now to the general scenario for modifiability. What can be as a part of source? This as a source can be, for example, the developer, the administrator, the end user, the person who will initiate this stimulus. It generally human. Stimulus. What kind of stimulus it can be? It can be some specific change that should be done, or we can talk about additional functions or modification of existing functions, or the source can these kind of changes that can make the qualities of system. So it means like make the system more responsible. Please increase the availability of the system, and please change the capacity of something. artifact. The artifact, it is portion specified what is to be changed. So it means specific component, or you have to change specific model, maybe some platform, maybe you have to change user interface or environment, something like this one. Environment. What it can be the value for the environment for modifiability? It can be compile time, build time, run time, the response. How can we respond for such stimulus? It's generally quite simple. The response can be make modification, test modification, or deploy modification. How can we measure our response that it will be clear for us? Do we cover this quality attribute response or not? So all possible responses take time and cost. This is common measures for such quality attributes. Although both sounds simple, it will be quite hard to measure. So if we are talking about the time, we can use a calendar or exact some values to measure it. So it can be number, size, complexity of affected artifact, some if words, as it would mention, calendar time, and so forth. Based on this general scenario, what kind of, here will be the example of concrete scenario in the next slide. For example, the input information sounds like this. The developer wishes to change the user interface by modifying the code at design time. The modifications are made with no side effects within 3 hours. Based on this input and general scenario, how can the concrete scenario looks like? In this case, the source will be the developer. Then to the developer, what he is initiated, he wishes to change a user interface. This is a stimulus. This is a stimulus using interface, but where he will make these changes? He will make these changes under the code. So artifact will be the code. Environment, at this time, it will be design time. What will be the response? Changes made, and they are covered by unit test. How can we measure? It was mentioned that no side effect within 3 hours. 3 hours is concrete value that can be the measure of this response. Here is one of the examples of concrete scenario that is built based on the general scenario. Next is how can we achieve the results to cover such quality attributes, such architectural characteristics. We can use different tactics, but when we are talking about modifiability, we have to keep in mind that we have to start from two main things. It is coupling and cohesion. So what it is? Coupling is the parameter that will describe how functionality or components or service are, what is the value of connecting them, how is there many intersections, how many request is between these components. And high coupling is an enemy of modifiability. It will be quite complex to make any changes in a system if you have high coupling between your components, if you are talking, for example, about microservices, then if you build your system and your microservices has quite a huge number of strong connections between them, and you are trying to change one of the part of the service, and that change requires changes on another one service, then you have high coupling between them. That is not good. So it will be hard to change of the system, and your goal should be to design and implement not the like implement, but yeah, but your goal have to always design the system in a way that your component will not be coupled by each other as much as possible. From the other perspective, we have another which is cohesion. And high cohesion is good, low cohesion is bad. What it is about cohesion? Cohesion is that how your, let's say, component, module, or service is responsible for some specific domain. If this responsibility is not strict and your logic or your domain area are in different components, then your cohesion is low, which is bad. So you have to make cohesion of the service as bigger as possible. What it means that only one component will be responsible for particular domain, and you will not put this responsibility across different components, across different services. Generally, based on this information, we can divide for our tactics for 4 groups. It is size of the model, its general coupling, cohesion, and binding time of modification. Now let's take a look what is under each of this group. So and we will start, I guess, from reduce size of the model. Reduce size of a model. There is one tactic which is called split model. So if the model being modified includes a great deal of capability, the modification cost will likely be high. In this case, if you will divide your model into several small modules, it should reduce the average cost of future changes. So this is one of the tactics that you will be able to apply. To split this, then changes of smaller components of smaller models will be less. Another one tactic is increase cohesion. And the purpose of moving a responsibility from one module to another is to reduce the likelihood of side effect affecting other responsibilities in original model. So increase semantic coherence. Let's say if you will notice that some of the model do not cover some purpose, then it means that this part of logic should be placed in a different model. Or sometimes it may require to create the new model, or it may involve moving responsibility to an existing model. But in case if some responsibility are not affected by these changes, then those responsibilities should probably be removed. By making these kind of changes at the beginning stage, or maybe even not the beginning stage, it's better to make it during design stage, but not when the code is already implemented. because the cost of such changes will be much more bigger when you will make these changes later. If you will be able to move such responsibilities between models as soon as possible, as great it will be. Another one tactic is reduce coupling. And here a group of tactics. And here we have several. This first one, it is encapsulate tactics. What kind of tactic it is? So encapsulation, it means you will use interfaces to communicate with a model. By using the interface, you divide this communication between models, so you increase the coupling. So the interface includes application, the API, and it is associated with specific responsibilities. This is generally one of the approach. How can you make or reduce your how can you reduce coupling between services? It is put the interfaces between the communication of them. In this way, your implementation, which is under this interface, can be changed because the interface will not be changed. Just only part of the implementation will change. So it means that another one user from another part who will use your functionality, he will still work with API, he will still work with the interface. So it means from his side, it will not require changes. This is one of the tactics that you can apply, not only for the design perspective, but even when you are just writing your code. I will tell you even more that this tactic is, if you will take a look, for example, to Java implementation in different perspectives, you can notice that it is applied in a different part of language. For example, if you will take a look how they organize such classes as integer, double, short, and so on, they extends from abstract class and implement the interface. If you will take a look for any collection class that implement data structures, let's say array list, it implements the interface list and extends from the class abstract list. So there is interface and there is abstract class. So each of these implementation are wrapped by interface. Moreover, if you will remind the data access object pattern, the same situation, and so worse. So another one tactic is use intermediary breaks of a dependency. What it means? It means if you have provide some dependency between two modules, then you increase your coupling, you increase the coupling by using these dependency. But in vice versa, if you will break this dependency between models, then you will reduce this coupling, which is clear. So the type of intermediary depends on the type of dependency. What can be the examples for this one? For example, if you will implement publish subscriber intermediary, it will remove the data producer knowledge of its consumer. So some information will be published, and then those who is subscribed, they will receive it. So you will break this direct dependency between them. Another one is it's just continue. It's restrict dependency. Is a tactic that restrict the model that a given model interact with or depends on. So how can you achieve it? You can maybe you can restrict a model visibility. It means that some of the developers will not be able to see some of the models. So you can use access modifiers for it during the implementation, or you can use authorization to restrict this ability to get additional dependencies, which will make changes or modifications in future more harder. Or by wrapping something, for example, and change the permission of that. Another one tactic is refactor. Is a tactic which means that you can take two models and by making some changes, which is okay, let's take a look from this perspective. You took two models and then you're noticing that they have duplicates in there is duplicates in each of them. So by the refactoring, you will remove this duplication, and each of this model will be responsible for particular case. Abstract common service, another one tactic. This tactic is in this case, where two models provide not quite the same but similar services, it may be cost effective to implement this service just once in a more general way. So instead of have different implementation of almost the similar things, think about that. Is it possible to design and implement functionality in a more generic way? Then in future, it will also decrease future cost of changes. Another one approach. So yeah, this is abstract common service, and different approaches differ binding. So there is actually some of the tactics under this. It's they can sound like component replacement, compile time parameterization, maybe sometimes use aspect, configuration time, use resource file, and so on. This is about this tactic. So next will be performance, and let's make some pause.